Okay. So here we go. We're going to learn statistics. All right, so this class is Introduction to Statistics, or it says Introduction to Statistical Reasoning, okay? Which means we're going to learn some of the math involved with statistics and how to use it, okay? So what is statistics? Why do we study statistics? Okay, so let me just start off by saying we study statistics and this is about how big I'm willing to write. So if it's too small for you, seriously, move up a few rows, okay? It makes a big difference. We study statistics to help us understand the world around us. And in particular, well, I would say any class you take, or almost any class you take, probably has this goal in mind, to help you understand the world around you, okay? Help you understand the world a little bit better in some way, okay? History helps you understand the past, so we can understand the world. You know, literature, you understand some writings, okay? Give you an idea of different perspectives. Okay, what statistics has to offer in this regard, in particular, is that statistics allow us to draw conclusions limited data or limited information. Okay. Limited data, limited information. We live in a time of maybe too much information. Okay? We are generating data every second. If just by owning a cell phone, you are generating tons of data, okay? If you have your GPS location turned on, which I have a feeling many of you do, you know, your phone is giving off little bits of information that's going up into the cloud and is basically creating a path of wherever you have been. Okay? Who you text, who you call, all of these things, all kinds of information being generated. Okay? But even then, we do not have access to all of this information. Okay? We might ask, how many emails are sent in a day? All right? And unless you have access to all the information in all of the internet, which no one person or entity has, that it's not available to you. Yeah, I mean, Google has a lot of power, and if you were had unlimited access to Google's data, which probably no one will have that kind of access, you still don't have access to all the data through Yahoo or all these other companies, and you might guess, but still, what can you do? Okay. So, so how can we even begin answering questions like that? Or if someone says, you know, what is the population of the world right now?
6.7 billion.
It's around 7 billion, but okay, 6.7, whatever. Okay. Now, is that an exact number?
No.
No. Okay. And how do we even come up with that number?
Census.
Census, okay, so in the United States we take a census once every 10 years, but do they take a census that often in other countries around the world? No, probably not, okay. So how are we coming up with numbers like this? Well, either someone's making them up, but we're estimating these numbers based on statistics, okay? And there's a few different notions of statistics. Statistics being just straight up numbers, okay? When you think of sports statistics, that's often what comes to mind. We have just, how many times did the person try to shoot the basketball? And how many times did the basketball go in to the net? We have lots of, so we have straight numbers, okay, or how many calls were received on your phone, yesterday. That would be a statistic. But then the study of statistics itself is then taking those numbers and doing something meaningful with them, okay? So rather than just having a bunch of numbers, we're trying to draw conclusions, okay? So the idea here is we do not have access to all the information. Okay. If somebody said, how many people are in the United States? How many people are living in the United States right now? Could anyone answer that question? Yeah, what's your answer? Okay, around 300 million. Okay, we did a census in 2010, and we'll do another census in 2020. And but we don't have an exact number. Okay, you go to the Census Bureau website, census.gov, and you ask, how many people are in the United States. They're going to give you some kind of number, but the fact is, we took a census already 5 years ago, and that information is vastly outdated, okay? We probably can think of someone born in the last 5 years, and we can probably think of someone who died in the last 5 years, okay? And when we took that census in 2010, those people were counted or not counted. So when we try to come up with numbers for how many people are in the United States right now, we have to have an understanding of how these numbers change. Okay, so we don't have access to all the information. If I said what percentage of the United States is female, what would you say?
51%.
Okay, so if someone says about half, so that would be 50%. Someone else said 51%. Are either of those numbers true?
No one knows.
Okay, no one knows. No one knows, all right? And the only way we can actually get that number, that percentage, would be what? We'd have to know exactly how many people in the United States are alive, and we would have to know exactly how many people in the United States, of those people, how many of them are female, okay? And so maybe we have exactly 309 million people, 623,454 people, and of those, 152 million, whatever, okay? We could list out these things, and that would be the only way we would have the answer to the question, what percentage of the United States is female? Can we agree that that's the only way to get the true answer to that question? Okay, so let's say what percent of the USA is female? Okay, and to answer, we need to know the numerator, how many females are in the US, divided by how many people in the US, okay, times 100%. That's the only way to get the true proportion or true percentage. So maybe you say, well, I don't need the exact percentage. I don't need the exact percentage out to 20 decimal places. I just need to know a pretty good number. Okay? And then you say, okay, well, how good of a number is good? Okay? You can say, is it okay to say, give or take 3%? Or does that sound like a lot? Because I could say I'm 99% confident that the percentage of women in the US is 50%, give or take 3%. Okay? That'd be anywhere between 47% and 53%. Is that too much, give or take, or what? Or are you happy with that? So, you know, that's a personal preference, okay? So you might say, well, give or take 3%, that's a little bit too much. I want a better number. I only want to know, give or take 1%. Okay, and I can say, well, I'm 90% confident that it's 50% give or take 1%. So anywhere between 49 and 51%. And probably I'm actually only 80% confident about that. You say, well, you know, depending on how confident you want to be about some kind of statement will change the amount of information you need. But with statistics, we can start to answer this question, you know, what percentage of the USA is female? You know, we got to give ourselves some breathing room, because we're not going to count how many people in the USA total we have. That's way too hard to do, okay? We might do it once every 10 years, and it's very expensive, and even then, the information is not 100% accurate. It's as close to accurate as we can get, but it's not 100% accurate, and it's quickly outdated, okay? So what do we do? So statistics, again, allows us to draw conclusions from limited data. And the idea here is that we have something called a population. The population is everybody who we want to study. population is too big for us to directly study. So in our example, in this question, what percentage of the USA is female? What is our population? So if we're saying something like 51% or 50%, if we say 50% of the USA is female, we're making a statement about the population, and in that case the population is everyone in the United States. Okay, so in our previous example, our population everyone in the USA. Okay. And the population has some kind of feature. Has a, a feature or a property which we call a parameter. What the parameter in our example that we wish to know is the percentage that is female. So we wish we could study the population, and we wish to know the exact value of this parameter. So if I say, let me just pose another question. And this question is, what is the median household income in California? No. The median household income in California. Okay, so the median means what? The middle point. So half of households make more than this amount of money, and half of households make less than this amount of money. Okay. So in California, median household income, it's around $55,000. Okay, around $55,000. Median household income. It's different from state to state, but that's something around there. Okay. Now, what is the population in that example? So I heard a few different things. So the population is not everyone in California, or not all residents. It's all households in California. Okay, all households. Because I said, the question was, what is the median household income in California? And so the population would be all households in California. And what is the parameter? That's the median household income, the median. So what we wish to know is we wish that we could know every single household in California and know the income of every single household in California. And then from there, we would find the parameter or a property of all of those households, and it would be the one right in the middle where half are larger and half are smaller, and we would find the exact household income of that one right in the middle. Okay? But again, even if we wanted to, even if we had a lot of money to spend and interview a whole bunch of people, we would not know the exact median household income in California, just because there's too many households to try to track down. And not everybody would be honest with how much money they make, okay? And so it's a very difficult question to answer. Okay? So we cannot study the population. That is the inherent difficulty that we face. Okay? That is what we mean by limited data. We cannot study the population directly. So instead, we study a sample. Okay? And so the sample comes from the population. We study a sample which comes from the population. And ideally, our sample is representative of the population. Because we cannot study this population directly, so we're going to study a sample instead. What we want is that when we look at our sample and we draw conclusions from our sample, we want those conclusions to say something about the population. Okay? We want to infer things about the population by studying the sample. So maybe we're still trying to answer the question, what percentage of the USA is female? Okay? So we take a sample. Let's say somehow we get a representative sample. Okay? Or we're not entirely sure. Okay? We draw a random sample. So here's an example. Draw a random sample of people in the US. And so let's say we get, we find 100 random people. And let's say 52 of these people are female. Does this say anything about the population of the United States? Oh, okay. Those of you who say yes, and those of you who say no. What is your reason for that answer? Yeah.
So if you just happen to get 100 people, and all those 100 people just happen to be male, then you would say 100% of them are male, so it's not an accurate representation.
So I'm picking 100 people at random. So you're saying if I select 100 people at random, I could get
It's
all
not
100.
as accurate as you would want it to be.
Okay, so if I draw 100 people at random, you're saying it's possible that I would get all 100 of those people to be male.
Right.
I would say it's so unlikely that I'm willing to say it's impossible for that to happen. If I'm picking 100 people at random, I would say it's impossible for it. If I'm picking 100 people from the United States at random, I would say it's impossible for it to be 100% male. That's a bold statement, but I'm not. It's actually not even that bold. It's okay. But okay. So we're saying we picked 100 people at random, and 52 of these people are female. Does this say anything about the population of the United States? Yes? No? Okay. Those of you who are saying yes, what do you think it's saying?
It gives a sample of the US population. That's what it is.
Okay, so these are just 100 people selected at random.
It's not 100% accurate, but it's just kind of showing representative kind of data that, I mean, say you repeated it, I mean, to build more.
Yeah, well, okay, but this is all I have. We've drawn 100 people at random. Okay, so some of you are saying it doesn't tell us anything, and others of you says it does tell us something, okay? Well, okay, I'll tell you what it says. It says, from statistics, if this actually happened, okay? And now this would be kind of a pointless study because we already kind of have an idea of what percentage of the United States is female, and so we probably wouldn't waste too much money on a study like this. But let's say we came from Mars and we had no idea anything or whatever, and this is what we're studying. What this study does reveal is it tells us that basically between 40 and, I would say 42% and 62% of the United States is female, okay? So what this data tells us is that, okay, 52%, give or take 10%, so meaning between 42% and 62% of the USA is female. Okay. So the fact that I drew a sample of 100 people and found that 52 of them were female tells me that the US is not entirely male and that it's not entirely female, okay? And based on what we're going to learn, the properties and statistics later on, based on our sample, what we know is that between 42% and 62%, I can be pretty confident that between 42% and 62% of the United States is female, okay? Now, almost all of you guys would probably know that already because you've been alive and you've encountered different people and you have a general idea that about half of the people you've encountered are male and half are female, okay? But I could ask questions, you know, of things that you are much less familiar. And information like this would be useful, okay? I could say, you know, what percentage of, I don't know, Germany's military is female? And you probably have no idea right now, okay? And so knowing that the numbers between, you know, even if it's a really wide range, is helpful, okay? Or what percentage of, you know, I could just come up with different things, you know. What percentage of people who drive a truck own a dog? Well, I don't know, okay? And the answer is different, okay, wherever you go. But this is what statistics allows us to do. Now, how did I come up with 42% and 62%, or, you know, 52%, give or take 10%? Well, I'm sorry. How did I come up with this give or take 10%? We're going to learn that later on in the course, okay? But I guess I want to make sure that this statement, when I say 52% give or take 10%, is everyone okay with the translation that it means between 42 and 62% is female? Okay. So this part, give or take 10%, we will learn later on in the course, okay? Now, there's a lot of stuff we have to go through, okay? We have to learn about just data and making summaries of our data in the beginning, okay? Before we get to making, this would be called a confidence interval, and that comes maybe in the 7th or 8th week, of course, of the class, 7th week or so. Ouch. Okay, why don't we take a short 10-minute break, and then